Okay, let's take a look at the combustion of hydrocarbons and some alcohols as well. This is the first one, the hydrocarbon butane, which you can buy these in a tobacconist, an aerosol filled with butane gas, which I've used to charge the naked flame lighter here, like so. So in here we've got butane gas, and butane burns with a clean flame, like so. So that's butane, C4H10. Let's take a look at hexane. I don't have any pentane, so I'm going to light it here in the evaporating basin. You can see that it burns with a fairly clean yellow flame, some black smoke there. In terms of score out of 10, let's give that a 2 for black smoke. So just extinguish that flame. That was hexane. Let's take a look at heptane. So hexane has the formula C6H14, twice as many hydrogens plus 2. This is heptane, hept for 7, so this is C7H16. Let's light it. Again, you see it's burning with a rich yellow flame, around about the same amount of black smoke, possibly a little bit more. If I give the last one 3, we can see more now in particular, more black smoke. So if I give the last one 3 for the burning of hexane, maybe give this something like 5, score of 5 for the amount of black smoke. That was heptane. Let's take a look at octane next. Again, I have some octane here in the evaporating basin. Oct for 8. Octane is C8H18. Let's light that. Burning maybe not just as well at the beginning, but there it goes. It's burning quite well now. Burning with a yellow flame, maybe some sign of a little bit of blue at times in the flame. Not seeing so much black smoke. I would have expected to have seen probably more black smoke. So that was octane. The next alkane would be nonane for C9H20. I don't have any nonane. This is decane, dec for 10, so this is C10H22. It's taking a little bit more encouragement to ignite this fuel. In fact, the only way that I could get this to burn would be to soak it into cotton wool, using the cotton wool as a wick. So this fuel, there is some of it in the bottom of the dish, but it's just not igniting. The next fuel is called methylbenzene. This is called an aromatic chemical. Methylbenzene. It's got what's called a benzene ring with a CH3 group attached to it. The benzene ring would be C6H5, and then we've got CH3 as well. Let's see if this burns. Again, it's a liquid. And yes, methylbenzene is burning. It ignited quite readily there. It's burning with a rich yellow golden flame, and you can see lots of black smoke. I think I would give that probably a score of at least 7 out of 10 for the amount of black smoke produced. Going to take a look at two cycloalkanes. The first one is cyclohexane, formula C6 C6H12. It's a ring structure. If you imagine a hexagon with 6 carbons, and each carbon in the ring has 2 hydrogens on it. So this is C6H12. It's a liquid, cyclohexane. And in a moment I'm going to burn cyclohexene, which is virtually the same except it has 2 less hydrogens. It has a carbon-carbon double bond in its structure. So let's see cyclohexane, C6H12, burning. It exploded there into flames. Again burning with a rich yellow flame, producing black smoke. In this case I might give it a score of something similar to the probably heptane score of around 4 or 5, something like that. So this is cyclohexane burning, C6H12. It's a hexagonal ring with 6 carbons bonded together with single bonds, and each carbon has 2 hydrogens in it. The ratio of carbons then is 1 carbon to every 2 hydrogens. Just extinguish that flame. You can see the amount of black smoke and soot that's building up in the evaporating basin from all this burning. Each one of these is being burnt in an individual dish, so a small amount of soot produced there. So I'm going to look now at cyclohexene, C6H10. So this is cyclohexene. It's a liquid. Similar to cyclohexane, except it's got a carbon-carbon double bond between 2 carbons in the hexagonal ring, and it has 2 less hydrogens. Now you may notice that this one is burning with a little bit more black smoke, so it's not burning just as efficiently. Give it a score possibly of 8 out of 10. This is C6H10, cyclohexene burning. If we look inside the dish, where you get a lot of black smoke, you usually get a lot of soot as well. So as you can see in there, we're getting soot building up on the inside of the dish. That's all of the alkanes I'm looking at. I'm going to go through a series of alcohols. In all cases, the alcohols will be 1-ols. If you're familiar with position isomerism in alcohols, sometimes the position of the OH group can change. In this instance, the OH, in all of the following molecules, the OH will be on the first carbon. I'm not going to burn ethanol for you. You've probably seen ethanol burning. This is propane 1-ol. It's a liquid. So this is C3H7OH, propane 1-ol. Now, alcohols have oxygen built into their structure, which helps them to burn, obviously. It's difficult to see the flame because it's yellow and blue, but you can just about make it out there. It does burn. This propane 1-ol is burning with a very clean flame, seeing very little black smoke, if any, here, and the dish isn't showing any signs of soot building up inside. So this is the alcohol propane 1-ol. Propane 1-ol has the formula C3H7OH. This next alcohol is butane 1-ol. Its formula has an extra carbon and an extra 2 H's. So it's C4H9OH. Again, it's a liquid. Taking a bit of encouragement to ignite. It is burning. So this is butane 1-ol. think you can see again it's burning with a clean flame, and there isn't any sign really of soot building up inside the dish. So that's butane 1-all C4H9OH. This is the next member of the alcohol family. This has an additional carbon and an additional 2 H's, in other words, an additional CH2 group. So this is pentan 1-all C5H11OH. Again, a liquid. Not bursting into flames exactly. So again, unless I was to burn this using cotton wool or something to behave as a wick, then it's not going to burn on its own. It's burning there with the help of the naked flame butane lighter. So that's pentan 1-all. It is burning as long as I keep the flame in it, and it is burning with a clean flame, producing no soot. But one would need to soak it in something like cotton wool to keep it burning by the looks of things. Well, there, it's defied me. It has actually started to burn on its own. You can see it burning now on its own. The naked flame lighter is not on anymore. And it's burning actually with a very clean, rich, golden flame there. Let's go to the next alcohol, hexane 1-all. So this is C6H13OH. Another CH2 added to the chain. Again, no sign of it bursting immediately into flames. But if I keep the naked flame lighter there, inside it will continue to burn. No sign of it burning with any black smoke or soot, but one would need to soak it into something that would behave as a wick to keep it burning. After a period of time, these alcohols do eventually burn on their own. Possibly a little bit more sign of some soot, but again, still burning with a rich golden flame with little or no sign of smoke. This is heptane 1-all, so this is C7H12OH. See how this burns. Again, it requires me to keep the flame in the liquid to make it continue to burn. So as we go along the family, they're not igniting as readily. Okay, we've got one last example here, which is an aromatic alcohol called, its old name is benzyl alcohol, formula C6H5CH2OH. Its modern name would be phenyl methanol. Let's see how it burns. Once again, it's not igniting on its own, and indeed I'm not seeing any flame there apart from the flame of the naked flame lighter itself.